Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 1 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2929, distribute candies among children too. So let's read the problem statement first. You are given two positive integers n and limit. We have to return the total number of ways to distribute n candies among three children such that no child gets more than limit candies. Okay, so these are the constants and value ranging from 1 to 10 to the power 6 and limit also ranging from 1 to 10 to the power 6. All right, now see this example number 1. So n is equal to 5 and limit is equal to 2, right? So we have 5 candies. Okay, so I can write 5 candies we have, right? And limit is 2, right? And there are total 3 children only, right? So let's say uh, this is child 1, child 2 and child 3. Okay, so let's name them A, B and C. All right, okay, so now here just see for child 1 first. Okay, child A first. Okay, so can I distribute 0 number of candies to this child? Okay, so I'm going to place, let's say, x number of candies to this child. Okay, so let's say initially my x value, okay, I'm thinking of giving 0 candies to this child A, right? So now the remaining number of candies is going to be that I need to distribute. So total number of candies is n. Okay, and here I'm giving x, so here remaining is n minus x, right? If I'm giving x candies here, so remaining is n minus x, right? So here if my x value is 0, so here the n minus x value is going to be 5 minus 0, that is nothing but 5. Okay, right? All right, so here tell me, can I distribute 5 candies to these two children? Is it possible or not? So limit is 2. Okay, so I can give max 2 candies here, I can give max 2 candies here, right? So here in total I am getting just 4, right? But what is my n minus x value? It is 5, right? So my n minus x value is greater than 2 into limit. Okay, 2 are the remaining number of children. Okay, and here I am giving the max. Okay, limit. Okay, so this is the condition right now. Okay, so if this is the condition, then this is not a right? Okay, so here 2 if I give, I can only distribute 4, but here remaining candies are 5, right? So sum of the candies A plus B plus C that I want to distribute, it should be equal to this 5. Okay, but here if I'm giving 0 and here I'm giving limit 2 and here 2, total 4, but there are 5 candies. So with 0 the answer is not possible. Okay, if I distribute just 0 number of candies to A, the answer is not possible. Okay, so if this is the case, just continue. Okay, continue, right? So this is one condition, right? Okay, so now this is for x is equal to 0. Now let's see for x is equal to 1. For x is equal to 1, then my n minus x value is going to be 5 minus 1, that is nothing but 4. Okay, 5 minus 1, 4. Now answer is possible, right? Now answer is possible, right? So here in this case, if you see n minus x, okay, so here my x value is 1. Okay, x value is equal to 1. So for a child A, I'm giving 1 candy, right? Now remaining number of candies n minus x. Okay, so its value is coming out as 4, right? 4, and I want to distribute this 4 to child B and child C. Okay, so can I say that let's say this 4 is nothing but my S value, some value, right? Okay, so B and child C. Okay, here I'm giving this much. Okay, I'm giving S, right? So here I need to make sure, few things here, right? So this is my child B and this is my child C, right? And this is the sum that I want to distribute right now. Okay, so now for second child, okay, for this child, right? So this value, okay, for second child, okay, so this value, it should be in this range, right? It should be greater than equal to 0 and it should be less than equal to you can say less than equal to limit, right? The limit value, right? Because I can assign 0 number of candies, okay, 1 number of candy or 2 number of candy. Okay, these are the three possibilities, right? 0, 1 and 2 in this case, right? Because my limit is 2, right? I can give 0, 1, 2, okay, for B, right? This is my possibility, right? Same way for C, I can write it like this now. For C I can write it like this: S minus B, right? S minus B, okay, for child number C, okay, for child C. Okay, so this value, it should also be in this range only, okay, less than limit. Okay, so S minus B value, it should also be in this range only, 0, 1 and 2. Okay, I should select like this only, in this range only, right? Okay, and this is fixed. Okay, X is equal to 1, A, this is fixed. Okay, I'm just talking about second and third child. Okay, this condition, right? Okay, with this condition I'm driving these two things. Okay, now here if you see, can I write this like this? Here this is for B. Okay, let's derive B from here. Okay, so can I just see this part, just see this part first? Can I write this part like this? B value, okay, B goes here, right? B goes here, so B value, it should be less than equal to the sum. Okay, can I write it like this? B is less than equal to sum. Okay, B goes here, right? Positive. Okay, so I can write it like this. Same way, now check this part. Okay, can I write this part like this? B goes here, okay, and limit comes here. Okay, so S minus limit, S minus limit, okay, and B goes here, so it is going to become positive, and I can write it like this. Okay, S minus limit, it should be less than equal to this B value. Okay, I can write it like this. Okay, so now check these two things. All right, from here I'm driving these two. Okay, so now here for the second child, okay, so I'm talking about second child. Okay, second child is nothing but B. Okay, second child is nothing but B. Now for B, I can select values. Okay, B, all right, so here I have to select the values. Okay, I have to pick one range. Okay, so here B, it is always going to be greater than equal to this 0. Okay, 0, or I can say 0, or I can say here S minus limit, right? S minus limit, S minus limit. Okay, this value, right? This is the range. Okay, and B, it should be less than equal to this limit. Okay, limit, I can write limit here, or it should be less than equal to B is less than equal to, I can say S value, right? S value. Okay, so here let's say S I'm writing. Okay, so now here this is the range I'm defining, right? This is the range I'm defining, right? So here I can also write it like this: 0, S is nothing but my S is nothing but uh, S is nothing but N minus X, right? So 0, N minus X minus limit. Okay, this is the range. Okay, for B, right? And it should be less than, S is nothing but N minus X comma limit here. Okay, I can write it like this. All right, now from here this is the range, right? So here these values are inclusive, right? Less than equal to. Okay, so now in our case, if you see, in our case the N minus X value is coming out as 4, right? So if I just take the example here, so 0, and here if I just place N minus X value as 4, okay, 4 minus limit 2, okay, and it should be less than equal to here B, and it should be less than equal to N minus X is nothing but 4, 2, okay, and here this limit is also 2. Okay, so here in this case what you need to do, you are taking this N minus X minus N minus X minus limit. Okay, so here from here let's take the max value. Okay, let's take the max value from this side, and here from here let's take the min value, right? Min value. All right, so here from here max value is 2, and from here the min value is 2, right? So we can just take 2 here because value is inclusive, right? Value is inclusive, so we can just take this 2, right? Okay, I can say 1. Okay, one value I can pick only from here. Okay, in this case 2, right? When my x is 1. When my x is 1. Okay, so now here why I am writing this max and min? This is your next question. Why I am writing here? Okay, so here let's see, if I am fixing this x is equal to 1 here, then for this I have to decide something, right? I have to fill this. Okay, so tell me, uh, in this n minus x, okay, n minus x is the value, right? So in this n minus x, the value is coming out as 4. Okay, can I place 4 here? Tell me, can I place 4 here? No, I can't place 4 here. Okay, n minus x, I'm talking about n minus x, just n minus x. Okay, n minus x, if I decide to place n minus x, so can I place 4 here? No. Can I place 3 here? No, because this is greater than limit, right? So I can place here 2, right? I can place here 2. Okay, 2 is possible, right? Okay, I can place 2 here. Okay, b here, check for this b. Okay, this b. Okay, so here I'm talking about this. Okay, so here in this side, n minus x is nothing but your 2. Okay, and 2, right? And here I can say 0 comma 2. Okay, all right. So here see, if I see these values 4, 3 and 2, okay, I have these many options 4, 3 and 2. So out of these I am just selecting the minimum one, right? I am selecting the minimum one, right? N minus x, okay, to limit. Okay, so whatever the minimum one, I am deciding that. Okay, min value in this range. Okay, same way here, if you check 4 we need to write 4 is total, right? So here can I select the value? Okay, so let's say if I pick this as, okay, or you can say this is for this main scenario. Okay, this main scenario. Okay, so we have to take the minimum among this. Okay, so we have to take, let's say, min of n minus x comma limit. Okay, we have to take the minimum among this, right? This is clear, we have to take minimum among this. Okay, now I can also change this to max scenario as well. Okay, so how I'm going to change it to max? So here instead of this n minus x, if I find this n minus x minus limit, okay, starting from 0. Okay, if I check from 0, so can I place 0 here? Tell me, can I place 0 here? So how I'm going to get 0? Okay, so I'm going to get 0 like this now, n minus x, whatever this total for, and here if I subtract the limit from it. Okay, limit value. All right, limit value. Okay, so if I place here 0, then with 0 this value is not right. Okay, okay, all right, then same way with the 1 also it is not possible, right? Okay, so in the limit I will add some values, right? In the limit maybe n minus x is 4, so let's say I add 4 here, okay, to make it 0, right? With this answer is not possible, I will get. Okay, if I place 3, then also answer is not possible. Okay, so from here 0, 1, 2 we have to take the max, right? So n minus x minus limit, from here we have to take the max value. Okay, so this is going to be the range. Okay, so that is why I'm taking max here, 0 to n minus x minus limit. Okay, and here I'm taking min. All right, so here this is done. Okay, so now this is going to be some range now here, like 2 to 2, this is one range, 2 to uh, 2, this is one range. Okay, so this is inclusive, right? This is inclusive, so I can just say uh, whatever the value, whatever my value here, okay, and whatever value my here. Okay, so let's say this is you can say you can say m a, and you can say mi. Okay, so I can write this as MA. Okay, this is MA, this is MI. Okay, so MA minus MI, and here I have to do plus 1 because this is inclusive. Okay, this is inclusive. So same way if I have 2 to 3, so I have choices now. I can choose 2 and 3. Okay, so here how am I going to write 3 minus 2 plus 1? Okay, so 3 minus 2 is nothing but 1 plus 1, that is 2. Okay, two values I can use, 2 and 3. Okay, so that is why I'm using plus 1, because this is inclusive. Okay, this is inclusive, right? So this is what you need to do, right? So this is the formula that we have to derive. Okay, so now let's write the code with this approach first. All right, so here a very simple code. So create one variable long answer and just set it to 0. All right, and then just run one loop. Okay, int I is equal to 0. So I here I am checking for the first child. Okay, first child. All right, I is nothing but for first child. Okay, so for first child I can give here 0, 1 or 2. Okay, whatever I have. Okay, so 0, 1, 2 until limit only I can assign for first child. Okay, let's say this is I x. Okay, this is I. All right, so here 0, 1, 2. Okay, it is fine. But if in case my n itself is 1, then I don't need to check until 2. Then I can only check until 1 only, right? If my n itself is 1 smaller than limit, then I have to only check until 1 only for this x. Okay, so that is why here I am going to use I is less than equal to math dot min of whatever the smallest value, okay, among this limit and n. All right, and then after that here I'm just going to increment the I value. Okay, this is for first child. Okay, and for the remaining portion, if I do n minus I, okay, for the remaining number of children, okay, if this value is greater than 2 into limit, okay, remaining are 2 children. Okay, if I just multiply with the max value, right, 2 into limit, and if this is the case, okay, then just continue, skip it. This is not possible, right? And otherwise in the answer you have to update value as answer is equal to answer plus. Here you have to take math dot min of n minus I comma limit. Okay, so this is the formula, math dot min of n minus I comma limit. From this we have to subtract this and plus 1, n minus x minus limit. Okay, and n minus x minus 1 is max. Okay, so here you have to write minus math dot max of 0, okay, among 0, and here n minus I minus limit. Okay, n minus I minus limit. Okay, and here plus 1, okay, inclusive, and then from here you can simply return answer. All right, that's it. Okay, so here in your case, if for x is equal to 1, what is the output you are going to get? So here you are going to get just 1. Okay, so answer, in the answer you are going to add 1, and that is fine, right? So if you place 1 here, then here just one option you have 2. Okay, that is why you are getting 1 only, right? This is the answer. Now in next case, if you place here 2, then for the remaining children, here in the answer you are going to get 2. Okay, 2 is nothing but 2 options we have. 1, we can use 1, or we can use 2. Okay, so if I choose 1, then this is my answer. Okay, if I choose 2 here, then this is my answer. Okay, so that is what we need to do, right? And from here we have to just return answer. Now let's run the code and see. So see, our solution is accepted, right? Now let's submit it. So see, our solution is accepted, right? Okay, so this is the solution for approach 1 of this problem. Now let's move to the approach 2 of this problem. So here in approach 2 we are going to use this concept stars and bars. Okay, so let's read the problem type first. How many non-negative integer solutions are there to this x1 plus x2 plus xk? This should be equal to this n. Okay, sum. So where x of I value should be greater than equal to 0 and n is also greater than equal to 0. Okay, so here these stars represents the items you are distributing, like candies. All right, and bars divide the items among different groups, like children. Okay, the formula for the number of non-negative integer solutions is n plus k minus 1, and here also k minus 1, right? So here n is nothing but the total number of candies items, and k is the number of the children variable groups, right? So in our problem statement, what we are doing, we have to return the total number of ways to distribute n candies among 3 children. Okay, n candies among 3 children. So in our case n is equal to 5, and we have to distribute among 3 children. Okay, so we are just using 2 bars here. Okay, so with just use of 2 bars we can form these 3 groups, right? So k is nothing but the number of children variables or groups, right? And n is the total number of candies, right? N is the total number of candies. All right, so here we can use star, right? So here I can give 2 candies to this child, I can give just 1 candy to this child. okay, and I can give 2 candies to this child. Okay, so star, okay, so this is nothing but stars, and these two are the bars. Okay, so these two are the bars, okay, in this concept, and these are the stars. Okay, so stars represent the items you are distributing, okay, and bars divides the item among the different groups, right, children's. So 3 children's, so we are just using 2 bars, right? So that is why we are using k minus 1 here, k minus 1 here. Okay, all right, and n is nothing but the stars. So you can say na it like this. You can also write it like this. Okay, n is nothing but stars. Okay, stars plus bars, and here bars. Okay, k minus 1 is nothing but bars only. And you, in our case, bars is always fixed, right? There are 3 children, so we are using 2 bars only. So we can write it like this for our formula only, right? Not in general, but for our formula only. We can also write it like this. Stars is nothing but number of candies plus 2 and divided by 2, right? Okay, this is a formula, right? Number of combinations, not divided by 2, just number of combinations. Okay, read it like this, number of combinations. Now see the example. How many ways to distribute 5 candies to 3 children, okay, such that the each child can receive 0 or more candies? So this is equivalent to solving x plus y plus z. It should be equal to 5, and x, y, and z, this value should be greater than equal to 0, right? So n is equal to 5, k is equal to 3. So you are going to write 5 stars, okay, 5 candies plus in our problem this 2 is fixed, right? 3 children are there, so it is always going to be 2 only. So here I can write 5 plus 2, and here 2 only. So I can write it like this as also 7 by 2. Okay, I am using by. I can also write it like this. Okay, 7 2, right? So how I'm going to get this 7 and 2? So formula is nothing but this value 7. Okay, the value that we have here, 7 into 7 minus 1, that is nothing but 6, right? And here divided with the 2. Okay, this 2. So here what I'm going to get, 7 into 6 is equal to 42, divided by 2, I'm going to get 21. Okay, so this is a formula for this. Okay, so this is done. Okay, all right. Okay, so now here this is done for our case. So this is the approach, actually, inclusion exclusion principle, right? So here intuition for this, we can solve this problem using a classical counting method, subtracting the number of invalid distributions. Okay, so here number of invalid distributions. Okay, number of invalid distributions. Okay, subtracting the number of invalid distributions from the number of total distributions. Okay, so here I think we are using total distribution only, from the total number of possible distributions. Okay, so you can say possible distribution, total number of possible distributions minus number of invalid distributions. Okay, now after this, by applying the inclusion-exclusion principle, we subtract the number of distributions in which at least one child receives more than the limit candies. Okay, so here at least we are using. Okay, so let's suppose these are the total number of possible distributions. Total number of possible distributions. So now we are going to subtract where at least one child gets more than the limit candies. Okay, so let's suppose this is the case. Okay, at least one. So in this at least one, okay, at least one simply means at least one means one or maybe two or maybe three. Okay, so I am deleting all these children's, right? Okay, at least one, right? And then at least one, so this is for, let's say, at least two. Okay, and let's say this is for at least three. So here if you see, in at least one only I am adding all this. Okay, I am deleting all this in at least one. So definitely in at least one only 2 and 3 will be gone. Okay, 2 and 3 will be gone already, but again I'm subtracting them. Again I'm subtracting all with at least 2. Okay, and again I'm subtracting this at least 3. Okay, so with just at least, I'm using at least one. Okay, not exactly one, because I don't know the exact count, right? I'm using at least one. So in at least one, all the childrens are going. Okay, the with 1 with 2 or with 3, all are going. Okay, and again here I am deleting again 2 and 3 again and again. Okay, so here what is happening, you see, by applying the inclusion exclusion principle, we subtract the number of distributions in which at least one child receives more than the limit Candice. Okay, so at least one child means at least one. Okay, this is case for at least one, this is case for at least two also. I will check, then also I will check at least three also, right? So in at least one only I am deleting all the children. Okay, one with two and three. Okay, I'm deleting all in the at least one only, right? Okay, so by applying the inclusion exclusion principle, we subtract the number of distribution in which the at least one child receives more than the limit Candies. However, in doing so, we may subtract some distributions multiple times, right? Specifically, the ones where two or more children receives more than the limit Candies. Okay, two or more children receives more than the limit Candies. Okay, so to correct this, we add back the number of cases where at least two children exceed the limit. Okay, at least two. Okay, so now I want to recover this. Okay, I want to recover all this. Okay, I have rated this again, this I have rated again. Okay, so I want to recover this. So to recover this, what I'm going to do, I'm going to add at least two. Okay, so if I'm adding at least two this time, at least two means 2, oh, and 3 we have to check. Okay, so if I'm adding at least 2, so definitely in this case 2 and 3 will be added automatically. Okay, if I'm adding at least 2, so definitely 2 and 3 will be added. But here what I'm doing, I am again adding at least 3 also. Okay, I am again adding at least 3 also. Alright, so this is the bad, right? I am adding at least 3 two times. Okay, in at least 2 I am adding 2 and 3, and in at least 3 I am adding 3 again. So now I have to subtract this at least 3 also, right? So but now we have overcounted the distributions where all the 3 children exceed the limit, so we subtract those again. So now we have to subtract these at least 3 also again. Okay, so in the end we are just going to remain with the valid scenarios. Okay, valid distributions only, right? So this is the formula that we are going to use. Okay, so what is the formula? So let's go through each case in detail. Okay, so this is very important. Okay, don't get puzzled here. So since children are allowed to receive 0 candies and we are distributing n candies among 3 children, so this is equivalent to placing 2 dividers among n candies. Okay, the number of such distribution is given by the combination. Okay, so this formula simple, n, okay, number of candies plus here number of star bars. Okay, 2 only in our case. So this is the formula, right? So you can also write it like this, C2 n plus 2. Okay, then now here from this we have to subtract this. Okay, we have to subtract this. So we give limit plus 1. Okay, candies to one child first. Okay, it is going to reducing the problem to the distributing n minus limit plus 1 candies among 3 children with possible zeros. So there are 3 choices for which child gets the extra candies. Okay, so here I'm going to use this 3. Okay, there are 3 possible children into C n minus, now I'm going to update this, right? So n is going to be n minus limit plus 1. Okay, n minus limit plus 1. Okay, so at least one child receives more than limit candies. Okay, more than limit candies. Okay, so we give limit plus 1 candy, right? So here n minus limit plus 1. Okay, this is the case. Then at least 2 children receive more than the limit candies. Okay, 2 children, so we give limit plus 1 candies to any 2 children, reducing the problem to distributing the n minus 2 into limit plus 1 candies among 3 children. There are 3 ways to choose the 2 children, so that is 3 into C2, here n minus 2 into limit plus 1 plus 2. Okay, so here we are just updating this value, okay, of the candies, right? All right, so we have to add this actually here, right? And then we have to subtract this. All 3 children receive more than the limit candies, so we give limit plus 1 candies to each child. So we are left with n minus 3 into limit plus 1 candies, right, to distribute among 3 children. The number of such distribution is this. Okay, so finally applying the inclusion exclusion gives the answer. Okay, so this total minus this. Okay, so here this is for at least one, right? So here we are adding 2 and 3, right? We are removing 2 and 3 two times, right? Okay, so to overcome this we are again going to add this. Okay, so here we are adding this, and for the 3 case, okay, so we are going to subtract this. All right, so this is the format that we are going to make. Okay, and this solution is going to run in of1 time complexity. Okay, so just go over these details, right? Okay, so now let's write the code for this. So here, let me just reset it, and now here, from here, just simply return. We have to call this cal method. Okay, here I'm just going to pass n plus 2. Okay, and then I'm going to subtract from this 3 into cal. Okay, here n minus limit plus 1, and here I'm going to just do the addition of this 3 into cal n minus limit plus 1, okay, into 2 plus 2, right? And then from here I will just use cal n minus 3 into limit plus 1, okay, and here plus 2, right? So this is what I'm going to call from here, and here I'm just going to simply use this method. Okay, define this method first, public long cal. So in our case, actually the bars are fixed too, right? So I'm going to simply here passing the x value only, and here I'm just going to write if x is less than equal to 0, less than 0. So in that case, just simply return 0. Otherwise, just simply return here. You can just simply return, you can say long, okay, x into x minus 1. All right, and here just divide it with 2. All right, okay, so now let's run the code and see. So see, our solution is accepted, right? Now let's submit it. So I hope that you guys are able to understand today's problem, both the approaches. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.